that you want to curry. That's what I want to talk about today in this code walk. So remember, currying is this concept in functional programming where you allow yourself to curry, or where you enable yourself to curry a function. And currying a function means that you take a function that has an arity higher than 1. In other words, a function that takes more parameters than a single one, or more arguments than a single one, and produce a series of functions that each take a single argument. So in other words, if you have a function of arity 3, you have a function that first takes an x, then takes a y, and then takes a z. You will then produce a new function that takes the first x, but that will then return a new function which takes a y. And when you then supply the y to that second function, you will get a new function expecting a z. And when you then finally supply the z to that function, then you supply all the arguments and your function can be invoked. And if I'm not getting the terminology incorrect, when you supply a single argument to this curried function, this is known as partial application. So let's think about something concrete. Let's say you have a function called add. And this add function takes an x and a y and then adds the x and y. So if you supply 2 and 3, you add 2 and 3, and then you'll get 5. But you can partially apply this function. If you curry this function, if you wrap this function by currying it, you will get a new function that only takes an x. And when you supply an x, you will get a new function that only takes a y. And when you then supply the y, you will perform the addition. So of course, this means that if you then create this curried function and then supply the argument 5, for example, you will now have a new function that adds 5 to whatever you add to it. So it has smaller arity, and some of the arguments have already been applied as partial application. But that's just a quick reminder about currying and partial application. That's not actually what I want to talk about. What I wanted to talk about is that I'm currently reading this book, An Outsider's Guide to Statically Typed Functional Programming. So far it's a great book. I'm not through yet, so I can't give you any more details. And full disclosure is that I got this book as a free review copy after asking the author if I could have one, after he posted that he would give away free review copies. But so far this book seems really interesting, and it seems like a great introduction to statically typed functional programming for those who are not heavy into math, for those who do not come from an academic background, or simply do not appreciate category theory or the complexities that come with it. Either way, I'll link that book in the description. But what I want to talk about is from that book. So one of the things that he mentions is that when you have a function that you want to curry, it of course matters which argument is the last argument, because that's the argument that you get sort of the most power from. That last argument is the thing that you can stick on in the end, and when you stick on that thing, that's when the function will be invoked. So this doesn't really matter when we have add function, because it doesn't really matter if we add 3 to 2 or 2 to 3. But for some functions it does matter, because you might have different types, for example, or the function applied in one order might not be the same as the function applied in the other order. This has a math name, but I keep forgetting what that is. So one example of such a function would be the take function. So I'm stealing his example from the book. So he talks about the take function. So you have a list, and you ask the list to take a number of elements. So you ask take n, where n is a number. So if you say take 3 from a list, then you will get the 3 first items from that list. So if it's a list of 5 elements, you'll discard the last 2 elements in some sense, but rather you would return a copy of the list where you only have the 3 first items. Or again, expressed generally, you get a new list where you have only the n first items, where n is the parameter that you're passing. And here, of course, it matters. You have 2 arguments. You have the list and you have n. And it matters whether you pass the list first or the n first. So one of the arguments is how many things that you're taking, and the other argument is the source from which you're taking these things. So the question he asks, which I think is a very good question, is should we put the list as the last argument so that we can partially apply the number first and then supply the list? Or should we put the number as the last argument so that we can partially apply the list and then supply the number as the last argument? And from my own experience, I think usually when we think about this, usually we would intuitively figure out which argument should be the last. It sort of feels like, okay, this is the thing that I want to vary the most, or this is the thing that would be most useful to have in the end, because I would appreciate being able to construct partially applied functions on the way. Think about, for example, this add function. If you throw this add function into a map, you can't do that because add takes two arguments. So when you're mapping, you need something that takes a single argument. So then you would, for example, partially apply it to a single number. So if you want to map a function that doubles all the numbers in an array, then you would presumably then partially apply the add function with the number 2. So this is what I'm saying, that the last argument matters, or which argument you choose to be the last argument matters. But in some cases, it's not as obvious which one we should have as the last argument. And then, this is what I wanted to talk about. He supplies an interesting way to think about this. So if you are thinking about whether you should put one argument or the other argument as the last argument, if you are from an object-oriented background, think about it this way. If the method that I'm designing would be an instance method, within which class would this instance method reside? So in other words, if we think about the take example, so take again, we said there are two parts. There's the list, the thing that we are taking elements from, the container of elements, and the n, specifying the number of elements that we should extract from this container of elements. So if you think about it from an instance method perspective, it can either reside in the number or it can reside in the list. So it's either an instance method on the class number, or it's an instance method on the class list. So does it make more sense to instantiate the list and then say take and pass 3? Or does it make more sense to instantiate a number, so new number, or I guess in a language that has literals, we would just say 3, dot, take, and then pass a list, right? Suddenly, it's a lot more intuitive, and suddenly, I guess most of us would say, well, clearly, the take method is a method that should reside on the list class rather than the number class. Makes more sense, right? It feels more useful. Of course, the other thing is not wrong at all. It's entirely doable, and it might actually be really useful to have a take method on the number class, and maybe you could use that to take things that aren't even lists, or you could take elements from things that aren't even lists. But now training off topic, the point I want to make is just that, in my opinion, I think none of these solutions are wrong, right? It makes sense to have a take method hypothetically on a number, and it makes sense to have it on a list. But they have different purposes and are useful in different ways. I guess you would agree that it's probably more useful to, in object-oriented programming, have a list and then apply a number to it, or pass a number to the take function that resides on the list. And that means that in functional programming, we need to think about it in completely the other direction, completely the other way. So if the function resides on the list class, then that means that list is the argument that needs to be passed last. Because in functional programming, data always comes last. But in object-oriented programming, we mix data and methods. So in object-oriented programming, if we have an instance method, then that instance method is within a class and is mixed with the data that we want to apply this thing to. So this is why I'm saying that functional programming and object-oriented programming are sort of the opposites of each other. Not really in that broad sense, but in this example we need to think about them in sort of opposing ways. But really, if you are from an object-oriented background, I think this kind of way of thinking about it actually helps a lot in figuring out, again, which argument should be the last argument in a function that you want to curry. And thinking about it this way, I think actually sort of helps develop an intuitive understanding between the fundamental differences between functional programming and object-oriented programming. Again, because data is mixed in with the functions, whereas in functional programming, we separate the data from the functions and apply the data to the functions as a last thing, or rather, functions are stated regardless of what data it is supposed to be applied to. Yes, we specify the types, but we don't specify the actual data, the actual contents that we want to apply the function to. Instead, we supply that as arguments, whereas in object-oriented programming, we mix the two. And that's why it turns out to be useful to use different orders for the arguments in object-oriented programming and in functional programming. I found this to be a particularly interesting excursion into the land of the differences between functional and object-oriented programming. So I hope you appreciated that as well. Anyways, remember to subscribe if you want to see more code talks or code walks like this. And on the channel, there are a lot of different programming videos like this and not like this. So I hope to see you over there. A link to the book is in the description. Thank you super much for watching, and I'll see you in the next talk. Welcome to another code walk. Let's talk about using programming to make the world a better place. Cheesy, I know. But let's talk about that. So today's code walk's a bit odd because here, somewhere around here, is actually Uhuru Peak of Kilimanjaro. It's super unfortunate, but it's extremely foggy, so you have to believe me. You have to take my word for that. Let me just show you some surroundings here. So I'm currently on a 8-day trek in an attempt to summit the Uhuru Peak of Kilimanjaro with 5 of my friends. So we're 6 people in my team. If you want to know more about that, check out some of the links in the description. I'm now at day 5 of day 8, so at this point I don't even know whether I succeeded in summiting or not. But yeah, down here you can see my camp. So this is where we sleep. But that's on a completely different note. I currently have some downtime, so I figured I'd use this thing another code walk. Something that time and time again comes to my mind is that when you know programming, you know a very specific skill, or let me put it this way, you have great powers. So it's like that Spider-Man thing. With great powers come great responsibility. I'm sorry, this is going to be cheesy, but I promise you it's really important. This is something that's actually pretty close to my heart. When you know programming, you really know a craft. Like you know something concrete. Like whether you're a carpenter, for example. I mean, it's fairly obvious that a carpenter has a very concrete skill that can be applied to do many good things and many bad things. And the same goes to programmers. Like, yes, we are building software and we're not building physical things, but more and more things in our societies are becoming software, or are becoming run by, or orchestrated by, or controlled by software. Which means that there are more and more chances for software developers to actually make a contribution to the world. And I actually think this is more and more in the sense that, let's say 10 years ago, not as much was in software. So let's even say something like Wikipedia. I mean, Wikipedia is information-centric. Like, it helps us distribute knowledge without requiring the one acquiring the knowledge to pay for it. But as more and more things become software-driven, like traffic lights, there are much more ways of using software to actually have a concrete impact on people's lives. Not just on a let me tell you how basis, or let me give you this piece of information basis. By the way, it's growing completely the opposite way. It's kind of just growing increasingly foggier, as you can see. So yeah, soon I guess my camp will disappear. Anyways, there's something that I like to think of, or what I like to reference in a lot of different scenarios, is Maslow's hierarchy of needs. So I know this is not perfect, but at least it's some way of trying to formalize and think about what people in our world need. Let me just pick this up on my phone. So Maslow's hierarchy of needs is a concept from psychology that says that on the bottom we have physiological needs, then we have safety needs, then we have love and belonging needs, then we have esteem, and then we have self-actualization. So it's like a pyramid, right? The point is that clearly it's not this black and white, and I think that it's sort of commonly accepted now, or generally accepted now, that it's not simple, and that it's not necessarily always a hierarchy, and that there is some, let's say, well, essentially that the edges are not that sharp, that maybe should be seen as like an indication, but not as like a general truth that always holds. So on the bottom we have physiological needs, and physiological needs essentially means we need to sleep, we need to eat, we need to pee, all of that stuff, right? Like we need to drink water. Like as a human being, as an animal, we need to do those things, otherwise we'll die, right? On top of that, we have safety. When you've satisfied the physiological needs, you have safety needs. That means we need to feel that we are not threatened, right? Like just think about the notion of a cannon, right? Like think about man being chased by a tiger or a lion or a moose in Sweden. I don't think that ever happened, but whatever. So making sure that we are safe as human beings is sort of the next step. Like when you have the physiological needs, you can eat and sleep, then we would want to feel safe. Beyond that, on the next step, we have love and belonging, meaning that if you feel safe and if you have your physiological needs satisfied, like you're part of a community, or finding someone to share your life with, for example, right? Like, even, let's think about, if I'm not mistaken, I think swans are one of those animals that pair up and then stick together throughout their lives. So like the swans actually have partners, and then they stick around their partner for the rest of their life. So that would fall under love and belonging. But like if a swan didn't feel physiologically satisfied, or didn't feel safe, physically safe, or physically and psychologically safe, it probably wouldn't look for a companion swan to share their lives with. And of course, yes, I know, again, like I'm well aware this is not black and white, because like that's the story of every French love movie. Like you give up your physiological needs and your safety in order to chase love. I understand, for sure, it's not the same. But I mean, again, like it's some indication. Above love and belonging, we have esteem. So I guess that would mean, I haven't read on this now, but I guess that would mean, and by the way, I mean, clearly I don't have internet. This is a picture that I have now on my phone. But the esteem, I guess, is feeling like you actually mean something, like feeling like you actually have to make some kind of contribution. I think they mean something like self-esteem. And then on top of that, the last piece of the pyramid, we have self-actualization. So, yeah, I mean, I'll actually avoid digging into these two because I'm not entirely sure what the difference is, and I would have to read up on these two in order to actually tell you the difference between these two. But again, like self-actualization, I guess this is where we have things like becoming an excellent programmer, or becoming an excellent pianist, or working for non-profits, or things like this, like making your role in the world matter, or making you feel like you have something to contribute, or that you matter in the great scheme of it all. So that's Maslow's hierarchy of needs. So my point with bringing that up is that I tend to often come back to this when I ask myself whether something is valuable spending time on. Not necessarily as a person myself, but just either me as a person or just generally for society. Like when I talk politics to people, I tend to bring up the Maslow's hierarchy of needs. Because a lot of things we can consider as important, but I think it's a mistake to say that all things are subjective, that all things are important from a subjective perspective. I think using Maslow's hierarchy of needs, we can argue that some things are objectively more important. And that's the way I tend to use Maslow's hierarchy of needs, because like free piano lessons for everyone would be fantastic, but it's not as important as guaranteeing food and safety for everyone. I mean, you're free to disagree on that, but I think that, I think that would be kind of silly. So anyways, the reason I'm bringing that up is that if you think about your role as a software developer, you could, in my opinion, the lower you can target something here on that scale, the lower you can go towards the physiological needs. My personal opinion, this is totally opinion-based, but my personal opinion is that role is more important. Right? So clearly I'm saying that the role of a doctor is more important than the piano teacher, and I deeply apologize for anyone who feels offended by that. I don't mean to offend at all, and it's unfortunate to have to talk about it on a scale. The point is that before everyone actually eats, I think we need to focus as a society on the physiological needs, right? Before everyone feels safe, we need to, as a society, focus on the safety issues, on guaranteeing safety. And I know that this is super tricky, and I am far from being even remotely good at this, even remotely perfect at this, right? It's always this struggle. I like to think of this, the word tension, I think, makes a lot of sense here. There's always, as a programmer, there's this massive tension between being extremely well paid and doing something extremely important that usually you don't get like anything for. And then you have to, I would say that the really sweet spot is to try to find something that's extremely important but actually also can be self-sustainable in a market economy. Like, for example, the work that Elon Musk is doing, like with Tesla. So actually having a massive impact, but doing so in a capitalistic manner, like given that we are in a capitalistic society, that's the way that's a way of making sure that talent can be attractive, because they can actually afford to pay people well, or pay people well enough so that they won't go to other places or take their talent to other places that were less important issues. So there's always this tension. That's kind of what I'm saying, between like as a software developer to take your skill and employ that skill within some place that actually really has an impact, versus going somewhere that simply just pays you well. Because there are plenty of jobs that satisfy the latter criteria for software developers currently. So there are lots of jobs for software developers that do anything under the sun, and if you re-examine it, you could question whether it's important, especially if you start to talk about Maslow's hierarchy of needs, right? Put yourself in perspective, put yourself in, compare yourself to someone else and say, okay, is what I'm doing important for the next generations, or for my future potential children, or for the children of my children, right? Or even just for people right now, people living right now. Yeah, I mean, again, like, not everyone thinks that that's a noble goal to strive for. Not everyone thinks that it's important to try to leave the world a better place than you found it. I mean, I do. And so, like, I would implore you to examine yourself in that way, and not in order to beat yourself up, right? I mean, the point here is that we actively reflect on this in order to become better. It's not like we do it and then we say, oh, I'm such a bad person, and la da da. I mean, that's not the point. The point is to say, okay, so now I am aware. That's step one. Then you think about what I can cope with doing and how I want to change, right? And then slowly move towards that. Nobody's demanding massive change from anyone. Or I mean, I should say, I'm not demanding massive change from anyone, nor from myself. I mean, again, like, I'm far from a perfect person, but at least I actively think about my role in society and the way I use my software developer skills to kind of make the world a slightly better place. And I implore you to do the same. To take this hugely powerful tool or skill that you have acquired and continuously is acquiring, and take that and employ that towards something that actually makes a difference. That actually makes a difference for someone else in a way that makes you feel like you are leaving the world a better place. So if we as a software developer community together could have some kind of impact, I'd be massively proud. Those are my 5 cents for today. I hope that doesn't make you super angry. If it does, please do absolutely shoot something in the comment and let's discuss about it. Again, I was really not trying to step on anyone's toes, so if you feel offended, please do remember that I think that everyone has an extremely important role to play in society, no matter how big or small your role is. I think the work you do is massively important. There are a multitude of jobs that need to be done. I'm simply trying to employ a bit of perspective when we think about how we employ our skills. Anyways, wish me luck on my flag. Thank you super much for watching. Remember to subscribe if you want more talks about code. Check out the channel if you haven't already. It's filled with educational videos on programming and screencasts and all the like. Thank you super much for watching, and I will see you in the next one. Day 6, last day before summit day. Check out this cool peak. Check out this peak. I can think of a lot worse ways to wake up. Welcome to another cold walk. In the last code walk, we talked about Postle's principle, also known as the Robustness Principle. But we also touched upon what is known as BWIM, do what I mean. And in this video, I just want to shortly talk about what the difference is between do what I mean and Postle's principle, or the difference between do what I mean and the Robustness Principle. So super shortly, Postle's law, or Postle's principle, or Robustness Principle states what you accept, but conservative in what you send. Conversely, DWIM, or Do What I Mean, states that you should not do what the user says, but do what the user means. And the key point here, or the key differentiating factor between these two very similar concepts, I think is whether the consumer, whether the user of the thing that you're designing is a program, is software, is a machine, or is human. So in DWIM, we say that we need to do what the user means rather than what the user says. And the user then is the user of your software. But that user is a human user. But in Postle's principle, or Postle's law, or the Robustness Principle, that user is a machine. So in other words, if you think about it this way, it doesn't really matter whether an interface, generally, I mean, an interface is an interface. It doesn't really matter whether an interface is for human consumption or is for machine consumption. But when an interface is for machine consumption, it's super important that that interface is rigidly defined and that there is an actual contract that users of that code can actually follow. And this is what the criticism to Postle's principle is about. The criticism is that if you design an interface that is to be consumed by machines, then that interface needs to be rigid, it needs to be very set, and it can't be in flux, or it can't be interpreted in different ways sometimes, but interpreted in other ways other times. And of course, I mean, the same thing goes for user interfaces. Of course, user interfaces should be consistent. But my point here is that I think when we talk about DWIM, or Do What I Mean, I think it's much less important to be extremely consistent. Of course, consistency is important because, like, users create mental models of the artificial thing that they're interacting with. Like, if you're interacting with a form, you as a user, you create sort of a mental model of that form and have this idea of how this thing behaves. I mean, it's like this funny notion of agency. Like sometimes people ascribe agency to things because it makes it easier to think about machines in that way. So like you could think of a light switch in your home as that when you press on, you ask the light to turn on. You ask the light to turn itself on, and in case the light actually wants to turn itself on, I mean, it's a decision from the perspective of the light, it will turn itself on. But sometimes it won't. But the point there is that isn't necessarily a useful way to think about a light. It's probably easier to think about a light as the actual electrical wiring that we have underneath. But when we have very complex systems and we have things such as web forms, it might actually make sense to think about user interfaces as having some kind of agency, or thinking of them as doing something on sort of our behalf. And if you think about it that way, it makes a lot of sense to think that a user might expect that when you enter information into a form and accidentally refresh a page, you wouldn't lose all the information that you've entered into the form, because the machine remembers you. The machine has a relationship with you. The machine knows that you enter the information, even though it technically perhaps doesn't, but it has some kind of representation of who you are, and it keeps that information for you until you come back. So I feel like I didn't make myself clear previously. Let's think about it this way instead. If you define a set of rules for how some particular thing behaves, and whoever is interacting with that thing is a machine, then it's super important that the rules that you set are strictly followed by the code base. So let's think about a form. If you design a form on the web, and if that form is to be consumed by a machine, if that form is to be filled in by a machine, then it's super important that whatever specification you made up for how that form works, that specification is actually the true specification, that is actually how the form actually works. But if you design a form for users, and so it's for human consumption, and then you define a set of rules, like maybe those are sort of the common rules that we all sort of tend to follow, or they are actually a specific set of rules for that particular form. You know how when under a particular form field sometimes there's a text that says in this field there needs to be such and such. There might be sensible deviations from that would be helpful to the user, that wouldn't perhaps make sense in a machine-to-machine scenario, but that would make sense in a machine-to-human scenario. So think about, for example, let's say accidentally inputting two @ symbols, right? I mean, it's a silly thing, but I'm just trying to think of that. Like that wouldn't make any harm. Like if I accidentally as a user put 2 at symbols, I wouldn't mind if you corrected me and made it 1 at symbol. Because I guess, I mean, you would have to make sure this is the case, but I would guess that 0 emails actually have 2 at symbols. So in that case, I mean, if you would do that on a machine-to-machine basis, that wouldn't necessarily be very smart, because then the machine don't know what to expect from your application. And that's super important. Like the programmer who writes the code might accidentally introduce a bug in their own code because they don't realize that they're actually sending double at symbols. And so this problem sort of just propagates, and that's the kind of discussion that we had in the last video. It spreads like a disease. But again, in the human scenario, when you're designing it for human consumption, then there might be a series of these scenarios that you might think of where you go, okay, I don't necessarily want to tell the users to do this because it's not necessarily what they should be doing. If they happen to accidentally do it, I do know what they probably meant instead of what they did, and then I can actually save them, quotation marks, save them from that scenario, right? Save them from that mistake. And that I think is still a super good principle. So in user interfaces, do what users mean, don't do what users say, or do what users do, of course. So that's it for today. Thanks for tuning in. Remember to subscribe if you want more books about code, and I'll see you in the next one.
Hey, you want to get leaner, stronger, learn some cool calisthenics, bodyweight skills, but right now you may need...
It's never easy, right? If you've been watching the Code Walk series, you might know that I previously talked about something called the Robustness Principle. I think I talked about it at least in the Risk of Substitution Principle video. So the Robustness Principle is also known as Postle's Law, or Postle's Principle. Presumably, I guess, because it's named after somebody who's called Postel. And this guy named Postel was prominent in the creation of the protocol TCP. And the reason I think it's not simple is because I came across this blog post the other day that argued that the Robustness Principle, or Postel's Principle, isn't a good idea. Actually, I started to think about it while reading this article, and I think it's a really good argument. It actually makes a lot of sense. So first of all, let's establish what the Postel's Principle is, or the Robustness Principle. So the Robustness Principle states that you should be liberal in what you accept, but conservative in what you send. So think about it in terms of a method. So if you have a function that takes some arguments, then you should be liberal when people send you incorrect arguments. I think metaphorically we can think about it this way. There's this concept from user interface called do what I mean, DWIM. So do what I mean, don't do what I say. So I might be saying something that's not entirely what you're expecting, but still you might understand what I was meaning. You might understand what I was probably intending to say, but didn't manage to say. So in user interfaces, I guess would be like, you're supposed to type yes with a capital Y, and then you type it without the capital Y. So then, okay, you just accept that anyway. Or, it could be a number of different things. For doing interfaces, right? Like, let's say you accidentally refresh the page and the stuff that was written in the form is kept in the form. Maybe that isn't entirely do what I mean, but in some sense maybe it would be. It's like a forgiving user interface. It's like you probably weren't intending to clear the user interface, so we assume that and we simply keep the information for you and refill the forms with the information that you had put in. But now I'm turning all off topic. So the point is, think about TCP. TCP is a protocol. So the point was that whenever somebody created an implementation of TCP, the guideline was that they should be, or the implementation should be liberal towards transmissions that are malformatted, packets that are malformatted. But again, it's probably simpler if we just think about it in terms of functions. So, if you're in a dynamic language, maybe this is a good example. If you're in a dynamic language, compiler or the lack of compiler, nobody's enforcing types. So you might be expecting a string, but somebody sends you an array. So one common thing that people do is that they treat everything as a list. So like if somebody sends you a string, you treat it as a list of a single string. If they send you a list of strings, you treat it as a list of strings. So that might be one way of thinking about it. Like the specification might say, send a list of strings. But you support also accepting a string because you assume that it might be a reasonable mistake, or it might seem logical for people to send you a string, so sometimes users of your code might do that. And that's one end of the spectrum. So one end of the spectrum is that you should be liberal in what you accept, right? So forgive others for their mistakes. It's part one. Part two is be conservative in what you send. In other words, don't make mistakes of your own, right? Accept when others make mistakes, but be really sure that you are not making mistakes yourself when you are sending packages. I mean, if you think about it, that sounds like a super smart idea. Right? Like if everybody followed this principle, it seems like the world would be a much nicer place. And that's kind of the argument that I was making in the previous video, in the disk of substitution principle video. But this blog post seems to argue the opposite. And it's actually, again, a very good argument. Here's the point. The point is that if we do this, if we encourage people, when, for example, specifying TCP, and then people build different implementations of TCP, and they are all liberal in different ways, then it's very difficult to predict how they will be liberal or how that implementation will be liberal. So suddenly, implementations of TCP aren't actually corresponding to the specification of TCP. And it might be that over the long term, if some particular implementations become more popular than other implementations, it might be that we sort of collectively start to adapt to that particular kind of behavior, which makes it sort of informal specification. And if you think about it, that's exactly what happened to HTML. Like, HTML with web development. The web browser were extremely forgiving. So, if I'm not mistaken, I mean, if you think about XHTML, from the beginning, there were no such thing as non-closing tags. By the way, I might be extremely incorrect here. It might absolutely have existed in the specification from the beginning, sorry if I'm wrong. But to the best of my knowledge, I guess we didn't have non-self-closing tags. Like, the non-self-closing, the tags that didn't have content, such as ING or BR, I guess they were self-closing. Like they had a slash at the end to denote that this is a self-closing tag. But then people started omitting that slash and just say BR without the self-closing slash, which made an extremely strange token in the language of HTML. But since browsers started to forgive them for that because they understood, right? Do what I mean. They understood what we meant rather than what we said. Even though we said something else, they started to forgive us for those mistakes. The problem is that we started to sort of adopt these conventions of omitting the slash. So suddenly, we had tons of browsers, and the browsers all had different specifications. Or I should say, the browsers started from the same specification, but they all had different interpretations. So it was very difficult to predict how any particular web page would behave in any particular browser. And this, I mean, that just seemed like a super good point to me, honestly. Because how would that be? How could that possibly be what we want? So the author of the blog post mentioned that with HTML5, these exceptions to the rules were actually specified in the specification so that the incorrect interpretations at least would be uniform across the different browsers. So Puzzle's principle, or the Robustness Principle, perhaps not necessarily accurate. There are some stupid arguments against it. If you want to read the blog post that I mentioned, check the link in the description. Thank you super much for watching. Remember to subscribe, and I'll see you in the next one. Let's talk about what I think are the three most important ideas in programming that I've come across this far. So number one, business is the only thing that matters. In other words, we don't develop software for ourselves. We develop software for clients to solve actual existing problems. And software is only valuable if we actually solve a problem for an actual person. And in some sense, this is of course trivially obvious. Of course, the case is that we develop software for end users. We develop software with the intent of somebody actually using them. But it's extremely easy to forget that and get stuck in the idea of that we're developing software for the sake of our own perfection, or for the quotation marks beauty of the software that we're developing. It's very easy as a programmer to get caught up in the idea that we want to make the software better, but we forget why we're trying to make the software better. So in other words, everything begins and ends with a requirement from the client. And just to make this super clear, for example, performance, like the speed of execution of the application, is another requirement. If there is no need to increase performance of the application, it's not a requirement. But of course, if clients actually demand that the software is performant,
E-type, P-type, and S-type systems. So I have a specific video on that. I'll link that in the description, so check it out if you're interested in that. But the point is that there's this book called something Lehman, sorry, I'm sort of forgetting its name, but so he argued that there are three types of systems. There are S-type systems, P-type systems, and E-type systems. And without digging into P-type and S-type systems, he's arguing that most of the time we're developing E-type systems. And what's special about these systems is that the requirements are in constant flux. In other words, we will never actually reach a point where we specify the requirements to 100%, because the requirements, by their very nature, is in constant flux. So in other words, the requirements keep changing as time moves by. And what's critical about these applications is that we're solving real problems for real human beings. Again, back to point number one, that actually solves a business problem, that actually solves something that has utility for some kind of consumer. So informally, I would say that 99% of the applications we build are of this type of an application. It's this kind of system, which means that 99% of the applications that we're building won't ever be quotation marks finished. There is no way of actually identifying a point or getting to a point where we specify all the requirements of the system, implemented all the requirements, and we have a quotation marks done system. I mean, with the whole notion of continuous delivery and agile and all that stuff, it seems like we as a community, as a software community, we are figuring out, and most of us agree, that software has to be delivered on a continuous basis. The days when you shipped, quotation marks shipped, signed off an application are long gone. But then, I think it's important to still remind ourselves about this, because I think we're underestimating the longevity of any particular software application. We're underestimating the lifetime, the time in which an application will actually live and actually provide value. So in other words, what I'm saying is that software, when we approach software, we need to approach software with the intent of maintaining that software forever. I saw a great tweet the other day that said something along the lines of that pushing to production is not the first release, it's the first sketch or the first draft or something like that, or the first iteration. I mean, it's really a good point. It's really a good way of putting it. Like, we are far from being done with the application. When we push the first version to production, we've created the first draft. We have a first version of the application. But the application, we should intend, or it makes sense from a business standpoint, to keep the application for a long period of time. It makes sense to build an application as though we are going to be in business for a very long time. I mean, if we build an application only to ship it and then forget about it, why would we do that? Of course, the app will become obsolete in a few weeks, a few months, a few years. Of course, we should aim for the long term. Of course, we should aim to build an application that we keep supporting and keep having clients and keep making money from over the long term. And to do that, we need to approach software in the same way we approach business. Or in other words, playing the long game rather than playing the short game. Instead of delivering software now and considering ourselves done, we think of our software as a service that we continuously provide to clients over a long period of time. But enough rambling about that. Let's get to the third point. So the third point I want to talk about is the notion of not providing estimates, or hashtag no estimates. There are various opinions about this, and I'm empathetic to the fact that a lot of people argue that in order to run any actual business, you need to supply estimates. You need to, upwards in the chain of commands, you need to supply estimates of how long you think particular activities will take to perform. I mean, I'm empathetic in the sense that I respect their opinion, but I still don't actually think that you necessarily have to provide estimates in order to run an actual business. If we think about the points number 1 and 2, if we approach our business, if we approach our software as a business that will live for a very long time, and we continuously develop and ship features to the clients that we deem the most prioritized features, why is it so important that we have to supply estimates? I mean, I assume the point is that we want to be able to do sort of a cost-benefit analysis. We need to be able to say, okay, is this feature more expensive to develop than this feature? And then we think about the utility that it provides for the end customer, and then we choose one of them. So yeah, that makes sense. And if you're going to do estimates for that reason, then at least do them relatively. Say this feature will be relatively more expensive than this other feature, or vice versa, rather than this feature will take X amount of hours or weeks or whatever. So when I agree to the notion of no estimates, I should perhaps refine that and say that I agree to the notion of no estimates in terms of time, where time is the unit of measure. But of course, it's kind of inevitable to measure sort of the complexity level so that we relatively can compare different features. I'm still not entirely convinced that we absolutely need to do this. But that's a separate discussion, and I need to do some more thinking before I can really have a strong opinion on that. I'm not sure, but again, I'm not necessarily convinced. But the key point to remember from that third point is that estimates are always wrong. I guess regardless of whether we talk about them in terms of complexity or we talk about them in terms of actual time, as in where time is the unit of measure, regardless, again, informally, 99% of the cases, our estimates will be wrong, and sometimes massively wrong. So whenever we can avoid to make estimates, definitely avoid to make estimates. I guess if we really take the really crucial part from that argument, that would be don't make promises based on estimates. So don't make promises where you say, yes, we will deliver this and this in that amount of time. It's really bound to fail. It's extremely unlikely that we will be able to deliver that on time. I mean, to be perfectly honest, from my own perspective, it's really difficult to say no when seniors ask for estimates and then we make promises to deliver based on those estimates. But we have to collectively try to get away from this kind of thinking about developing software. We can't make reliable promises in terms of how quickly we will be able to develop a particular thing. So it's better that we rethink the way we develop software and actually base it around a much more iterative approach. We step by step refine. And again, there's no need to think that that would be necessarily worse for business. But I'll stop here so I won't start rambling too much about things that I don't actually know a lot about. Thank you super much for watching. I hope this made sense. Please shoot something in the comments if you agree or disagree. Remember to subscribe if you want more talks on programming, and I will see you in the next one. Full circle as quickly as possible. Probably this is just another way of talking about lean, but the topic is so important that it's probably even beneficial to think about it in many different ways. Regardless of whether you are self-employed, an entrepreneur, or whether you're working for a company, I've come to believe that this is the single most important thing we should know as programmers. The single most important thing that we should keep reminding ourselves of and keep following. So let's talk about what I mean with going full circle. There are a lot of interesting and important concepts from Agile, such as being close to your customer and not putting a lot of weight on documents, in other words, favoring interactions and all these different things. Please do check out my other videos on the Agile Manifesto if you're interested in that. But to really understand, the key point is really that what we're looking for is that we want to be able to deliver useful software as quickly as possible to the client. And the key point here is that what we're delivering is working software. We're not delivering working documentation, we're not delivering papers, we're not delivering specifications, we're not delivering images. The thing we're actually delivering is a fully functioning prototype. Something that is a fully functioning piece of software that doesn't necessarily do everything that the client would wish or want it to do, but at least does something. In other words, we bring the client something that has some value and isn't just a mock-up. It isn't just a non-usable prototype. And that's the key point. It's extremely easy to forget
that we need to develop our software all the way, the whole full stack, right? From the requirements all the way down to the actual working software. And this is what I mean when I say full circle. It's very important that we close the circle completely and not just deliver, for example, a specification. So the reason I'm saying this is that I consider myself to be a person who's very fond of agile and who struggles a lot or really tries to follow agile principles and really tries to deliver as quickly as possible, keep things as lightweight as possible, and all of these other different ideas. But still, we found ourselves in this project in a situation where we spent a lot of time without actually delivering anything useful to the client. So I have to stop and ask myself, how did we actually end up in this position? How did we actually end up in the position where instead of having a useful piece of software as quickly as possible, we sunk a lot of time into producing documents, even though I'm extremely fond of the idea of not producing documents, even though I'm extremely fond of the idea of keeping it agile, of going full circle as quickly as possible, of delivering working software as quickly as possible. The way I think about it today is that what I think happened is that and I assume other people on my team, were actually kidding ourselves. Unconsciously, right? We thought we were going full circle, when in fact we weren't really actually at all. So we thought we had went full circle, found something we could iterate upon, and then we kept on iterating upon that. But as soon as we came to a point where we really started to push a bit harder, right? We tried to really close the circle and really trying to deliver the thing we're about to deliver. That's when we discovered that actually we had skipped a lot of steps. Actually, there were a lot of steps missing. And when we started to take those steps, we realized there were a lot of things left that we have to do that are extremely costly, which put us in a situation where we had gathered tons and tons of requirements, and suddenly we were in this position where, due to discovering that we had a lot of costly activities left, we started throwing out requirements. We started aggressively reprioritizing and removing some requirements, because due to these new costly activities, we simply couldn't afford performing all of the activities or meeting all the requirements that we had intended to meet. And you can make of this story what you will, but what I make of the story is that I actually think that this was an extreme waste of time, not just of my time, of other people in the project, right? It was an extreme waste of people's time, and by proxy then, an extreme waste of money. Because we've spent a lot of time constructing requirements that we won't actually build. Probably never. And it just absolutely shocks me that we could end up in this situation, given the sort of, at least the background that I have, given the perspective that I have on software development. I mean, I can't help but to ask myself how I could have possibly been that blind. And this is why I'm saying the only rational reason that I can see is that I sort of subconsciously was kidding myself. And that's the reason I'm making this video. I really want to caution you against not going full circle. And quite honestly, I really want to caution myself, or make this as a reminder to myself, to always go full circle. Because now I know that I've made the mistake, and apparently it seemed it was quite easy to make that mistake. In my case, this means that we spend lots of time, lots of resources, lots of manpower, lots of, by proxy, money, constructing and refining and perfecting requirements of ideas that we never actually in the end used. We constructed extensive requirements and actually documents, even though the documents were lightweight. That's I guess what tripped me up, because I'm saying that because the documents are lightweight, we have to be doing the right thing, right? Because I'm not producing extensive requirements documents. But the problem was still that we were constructing requirements documents rather than producing working software. What we should have done is that we should have identified what the minimum product is, what the minimum viable product, what the minimum possible deliverable that we could construct is, and then construct that, focus our energy on that. So I think the problem here is that I think it's easier than you would imagine, at least it was easier than I imagined, to fool yourself that what you are constructing is the end deliverable, or is the format, is the shape, is the structure of the end deliverable. When in fact it's really not. It's really just another requirements document that sort of somehow resembles a deliverable, somehow makes you feel that it is a deliverable. And this we have serious first-hand experience from, and it's, again, still shocking to me that we didn't do anything about this. We had a very difficult time getting stakeholder engagement, getting discussions, getting heated debates around whether the requirements are fulfilled or not, whether we are missing things, whether we are fulfilling requirements, whether we are doing anything bad, or whether we are doing anything good. We had a very difficult time actually getting these discussions going with our stakeholders, with our customer, our clients. And I would venture to say that the reason for this was that our stakeholders probably understood that what we had constructed wasn't a deliverable. It wasn't an early version of the thing that we're about to deliver, the software that we're about to deliver. But rather we had constructed arbitrary, I shouldn't say arbitrary, but rather we had constructed requirements documents, hypothetical ideas, or models that we have put down on paper but hadn't actually implemented software. They knew that we hadn't gone full circle. So it's my belief that because of that, they didn't want to engage with us. They didn't want to engage with the product. When we then really hustled up, really spent a lot of time creating that first full circle deliverable, when we really realized that we were actually very far from that full circle deliverable, that's when suddenly it was like just everything dropped, right? Suddenly we had massive engagement from stakeholders. Suddenly people cared a lot. Suddenly we could have very useful discussions with stakeholders and discuss where we were hitting the requirements and where we were missing the requirements. All because we had now actually gone full circle and we could actually talk about the software while actually looking at the software. I think the thing that was really tricky in our scenario is that because we were working with simulation and because we were working with non-visual simulation, we couldn't necessarily show the program running to our stakeholders because the program wasn't necessarily visual, it didn't necessarily have to be visual, and we, for reasons of speed, didn't want to spend time constructing visuals. But what we had to realize is that we had to go full circle with the steps. We had to actually produce diagrams. We had to actually run massive amounts of simulation with the realest data that we can possibly imagine, and then do actual statistics upon that and present these actual statistics. And at that point, we could have a discussion about whether the assumptions that we put into the simulation actually made sense or not. Because now we had some output to actually discuss that wasn't actually hypothetical. So the full circle, I would venture to say, was, in our case, at least for me, not necessarily obvious. It was not necessarily obvious what going full circle actually meant. But if I would learn from this mistake, I would have to think about it this way. I would think that next time I would spend a lot more time really trying to figure out what full circle means. And if I can't get stakeholder engagement, I would assume that I haven't gone full circle. And instead I would then push forward and try to see if I can go full circle, try to find a different kind of deliverable, a different format of the deliverable that actually engages the stakeholders. So the sort of litmus test or the sort of watermark is, do you have massive stakeholder engagement? Do you have useful stakeholder engagement? Unfortunately, that's of course not the only checkup we can do, because I guess sometimes you also just have very engaged clients or stakeholders, so then they would be engaged regardless of whether you have actually gone full circle. But the key point is really, you need to find something that is deliverable. You need to find something that is deliverable. You can think about it this way. If all of the developers left the project, you should be able to have tangible results at all times. There should always be a version that is the production version that isn't hypothetical, that isn't a prototype, but actually is something that is deliverable, something that is runnable, something that is public. If everyone left at any point in time, you should have shippable software. Boom, everybody disappears. Okay, the latest version is still published, you've got it, it works. It doesn't do all of the fancy things that we want to do, but at least it works. That, I guess, is the really good test. And we were far from that, right? We had requirements. Because if suddenly all of the people had left, what would the stakeholders say? They would say, okay, well, all programmers have developed a bunch of ideas about how to operationalize these things into a simulation. That's not a deliverable, right? That's a massive catastrophe. So, let me sum up. The key point is this. When developing software, regardless of whether you're an entrepreneur, you're an independent programmer, or you're working for a firm,
The single most important thing that we need to go full circle as quickly as possible. Go full circle. Find a deliverable. Find the format of a deliverable. Find in which way you're going to deliver your actual software. Deliver that, and then refine it, and refine it, and refine it. And this is how we get stakeholder engagement. And this is how we consistently stay in a state where at any point in time we have working software. Do not iterate on requirements. Do not construct requirements documents and then iterate upon those and iterate upon those. You might find yourself in a situation where you waste lots and lots of time. So instead, find a way of delivering software. Find a way of delivering software, deliver it, and then iterate upon that. Go full circle as quickly as possible. Please don't repeat my mistake. I'm sure lots of other people before me have repeated it, and I should have really tried to listen to them in order to not waste as much time as I actually did. This was, quite honestly, a really painful experience. That's it. Thank you very much for watching. Remember to subscribe if you want more cold talks like this. Shoot a comment if you agree or disagree, and I'll see you in the next one.
Hey, can you see what I'm doing wrong with this exercise right now? Take a closer look. This is the plank, a common exercise. Because now, as you can see, we are in a secure atmosphere. We're not in a remote atmosphere anymore. But then how...
people are often very, I shouldn't say afraid, but people are not very quick to delete their code. And I recognize myself in that behavior massively. In other words, early on, in my very early programming days, whenever I had written a piece of code, I was very hesitant to deleting that piece of code because probably it took me a very long time to sort of figure out and craft all that code. And of course, when you get more advanced in programming and when you start to move into version control and things like this, when you have version control, it's very unlikely that you'll be as afraid to delete code because you'll always have your older versions. And even before you're in version control, I would highly encourage you to actually keep versioning your programs. You can just duplicate the folder in which your code resides so that you can more confidently make a new change. But essentially my point is this, that deleting code is an extremely important part of learning to write better code for two reasons. One, because deleting your code allows you to refactor your code. In other words, if you get completely attached to your current code base and refuse to sort of change it because you've figured out the problem, well, how are you going to learn by refactoring? It's only by somehow deconstructing the code that you've already written that you can make new, better code. Secondly, and perhaps more importantly, when you delete large chunks of your code, you have to somehow rewrite something that's very similar to what you had before. And that rewriting of code is a very useful lesson. Repetition is the mother of all learning. So what I'm saying is that even if you would delete a chunk of code and rewrite it exactly the same way as you wrote it before, I strongly believe that you'll actually understand the code more as you rewrite it the second time, right? Because even if it's almost sort of mechanical, you internalize sort of idea about the program you're writing. In some sense, you can think about it, I usually think about it this way, like we build mental maps, like we build the mental architecture of the code, of our code base, in our mind, so we sort of visualize it in our heads, and then we execute that in terms of typing it on the keyboard, typing it into our code editor. And the more times you do that, the better you understand the architecture, the better you understand the sort of structure of this mental building. And as you do that more and more times, you'll have an easier time to identify potential refactorings because you'll think about the structure, you'll build up the structure in your head, and then you'll say, maybe this thing is actually quite strange, I should sort of do it this or this way instead of that and that way. Going back to this idea of being afraid of deleting code, I would ask myself this question: why am I afraid of deleting code? I would assume that a lot of times the reason that we are afraid to delete code is that we are afraid that we are incapable of reproducing it again. In other words, incapable of rewriting this piece of code that we're deleting. But if that is the case, then I would actually see that as a warning signal. Think about it this way. If you're unable to reproduce the same code, I would think that suggests that you've identified a very simple solution to the problem at hand. In other words, you haven't really internalized the problem at hand. In other words, you've hacked up a solution, right? You spend lots and lots of time bashing at the program, finding a solution that isn't understandable when you look at the solution again. Because when we find the solutions to problems, I like to think of it this way. I like to think that under every problem, there lies a beautiful abstraction. There lies a close to perfect abstraction. This is a topic for another discussion. And of course, even another discussion is whether you should always look for that perfect abstraction or whether you should stop at some point and just say that this is good enough. As you might guess, I'm of course of the opinion that there are indeed scenarios where you shouldn't look for the perfect abstraction. But remember that in this talk now, we're talking about learning, right? We're not talking about programming when you're programming in a scenario where you would necessarily have to move fast and move with as low cost as possible. Then I'm just saying that in the early days of programming, or when you're learning programming in general, it's very important that you do spend time eliminating code and then rewriting that particular piece of code. Again, in search of some better abstraction. What we're talking about then is essentially refactoring. So it's kind of like that saying, you shouldn't practice until you know how to do it. You should practice until you don't know how to not do it. You should practice until it becomes intuitive. You should practice until it becomes sort of intrinsic part of you. You internalize the information and the procedures. You internalize the idea of the architecture. You internalize the steps that you take when you face problems of that similar, or that are similar to the problems that you're facing right now. So essentially is, do not be afraid to delete your code, even if you are afraid that you might not be able to rewrite it. If you're afraid that you might not be able to rewrite it, that is an excellent indicator of the fact that you actually should delete the code and try to reproduce it. And if you're still afraid, you do exactly the same thing, right? For every time you do that, you'll be a little bit more faster in reproducing that piece of code. And hopefully, with every time, you'll reproduce it slightly better. And this is how we become really good programmers, in my humble opinion. Thanks for watching. Let me know in the comments if you agree or disagree. Remember to subscribe if you want more stuff like this, and I'll see you in the next one. So today I want to do something a little bit different. Usually I keep my videos very concrete and practical, but today I want to talk about more of a soft topic. And sorry if this turns out to be almost kind of a rant, but I want to talk about what I think of as the keyboard generation, or the desk generation. No matter if you have a sitting desk or a standing desk, we're still sort of the desk generation. So the reason this topic has become kind of more important to me now is that I'm developing this sort of problem with my hand, all the way from the lower parts of like the hand and up to the shoulder. And reasonably, I'm guessing this has to do with the amount of time I spend in front of a computer. I think my friend put it nicely when he said that it's easier to count the hours you're not spending in front of a computer rather than counting hours you do spend in front of a computer. That goes for a lot of us, and maybe that goes for you. And that's not because I like play games during the night or anything like this. I mean, especially now, I really try to focus solidly on getting like 8 hours of sleep. But the thing is still that my full-time job as a PhD student, it means that I spend a lot of time in front of the computer. I'm writing simulations, so I do a lot of programming. So my full-time job, daytime job, is at the computer. And then I do entrepreneurial stuff. I do this kind of stuff, which means that I also do video editing, which is also in front of the computer at nighttime. And I mean, that's not I'm not trying to complain. I mean, I love that stuff. That's fantastic. That's why I do it, right? The problem is that it necessarily has to be in front of the computer. And this is also kind of a reason that I'm doing these videos outside of the computer. I mean, I know that some of these topics would be much more suitable to do in a screencast format, and I'm trying to do as much of that as possible. It's just that it's really difficult for me to rationalize spending even more time in front of the computer. I mean, at some point it kind of and the Chomsky hierarchy. I mean, this way, this is from some university, I can't remember which one, but the guy's very entertaining, and it's an excellent place. I highly recommend you watch that. I'll post that in the description. But if you think about the tokenization step of a compiler, in other words, when you read the string that is the program, and then you tokenize the pieces of the string into different things, such as the keyword module, the keyword class, right? When you do that step of the compilation process, you can reduce the search space of possible values or possible tokens that you can have in a particular location, depending on what tokens you've seen before. So, if you, in C#, for example, if you see the keyword class, you would expect it to be followed by the token curly brace. And if you see the token or the keyword semicolon, for example, you know that the line has been terminated, which means that the next symbol has to be from the set of symbols that are allowed to be used at the beginning of a statement or expression. So you can't start a new line, with equals, for example, in some particular language, right? I guess that would be the case in C#. It doesn't really make any sense to start a new expression with equals in that language. It totally depends on the language. My point is that the search space is, of course, I'm not saying that this is something strange. I mean, I'm just trying to really underline that obviously the size of the search space is less. You have a set of expected possible tokens. You have a set of tokens from which you assume the next token would be off when you're parsing a program. So it's not as in that the next token can always be any of the possible tokens at any given time. The search space is smaller than that. So the reason I'm saying that is that this brings me to thinking that, I'm not saying it's trivial, but is it really that complicated to start typing individual characters and start typing tokens of expressions? Why am I typing, when I want to construct a string, why am I typing string? Why? Because at that particular location, when my cursor is at that particular location, there's a set of possible things that I could type. So could I somehow navigate that hierarchy of things that I could type there? Whether that's through voice, or whether that's visual, or something completely different, whether that's like mechanical, right? You could even imagine holding the levers. I'm not saying that would be a progress, but I'm just saying hypothetically. It doesn't matter. I'm just saying that to me it sounds like moving away from typing the individual characters seems like a smart thing to do. Any problem in computer science can be solved with another level of abstraction, except the problem of too many levels of abstraction. So to me, this feels like a natural step. Probably I'm underestimating the complexity, right? Because otherwise I guess we could have this. But I'm just trying to be another person pushing for this and saying that I would so welcome this development if voice control programming started to act on the token level rather than on the character level. I'd jump into it. Early adoption, right? As soon as it works kind of okay, I would totally jump into it. That would be fantastic. A colleague, a research colleague who is finishing up his dissertation and works on visual programming. So again, it's less trivial than you would imagine. But there are ways of producing programs using visual constructs rather than using individual characters. And you know about this. I mean, this really feels like, try to think ahead in time, right? Like this feels like inevitably the evolution has to move in this direction. This is what I'm saying the keyboard generation or the desk generation, right? You could say the monitor generation or the terminal generation. As we move into VR, for example, think about this. As we move into VR, you'll program monitor report style with a VR set, right? I'm still waiting for VR programming. Have your VR set and then a visual keyboard, and then you use your control on your visual keyboard in your VR work. Doesn't that seem totally inefficient? Or if you want to put your VR set on and then quickly on your physical keyboard. Actually, what you should be looking for isn't that more like you put on the VR set and then you shuffle things around using your VR controls, right? In the 3D visual world, you shuffle things around and through that you compose a program. Because that's what you're actually doing, right? We're not writing programs, we're composing programs on Lego bricks, where if you put them in particular orders, you get a particular outcome. You take these Lego bricks,
stack them here and there in particular combinations, based on that, you get your program. So isn't that more like old font? Doesn't that just kind of make you go, oh, hey, cool, the program in that way? I just want to crazy, man. That sounds super awesome. And it just somehow just feels kind of natural. It would be like taking physical things and composing these different physical things. It's suddenly like it's suddenly a lot more like building something, which is in my mind as it should be, which is what programming actually is, right? Building something. It's just that the complexity is so high, so it's difficult to depict living in the physical world, but in the digital world, right? I really actually do. And of course, there's the whole notion of like the actual natural language portions, like variable names, method names, and class names, and things like this. And honestly, I have no solutions for that. I don't know how to do that. I really should go like voice commands and then autocorrect or keyboard or I don't know. But multimodal, use multiple combinations. You can preserve big style, right? You don't have to show all the buttons at once. This is all the visual representation. Let's then move into usually reorganizing the programs, and then at the early applications we'll use the keyboard kind of a name or something like this. I don't know, I mean, we'll find solutions. But just think about the implications. So first, you can get off your desk. Wouldn't that be amazing? You could still sit at your desk. If you want the person to just sit down, put on the earset and go, right? I mean, people have all kinds of body variations, so of course, this might not necessarily be improvement. You have to do bigger motions with the hands. This might not be an improvement for all people, but for these people, they could still use the keyboard side, or they could use the order movements. I mean, quality and size does not have to go. I'm just saying that you can expand or think about how to write programming. You can expand the methods of how to write programming. So that would be one thing. That would get off your desk. Another thing that you can have your programming environment with you all the time. I mean, just think about how bulky a big physical monitor is. Think about how we look back now at old TV screens, right? And we say, oh, it's so silly. I can't believe we have these massive big TVs, right? We'll probably do the same thing for computer monitors. They're bulky and they're heavy, and you have this massive keyboard and all that. It's not just software anyway. Why do you need these physical things? So what I'm trying to push for is portability. If you think about cloud computing, for example, this is just kind of another step in this direction. The situation used to be that if you were running your own product, you had to run your own server. Back in the days, you had to deploy your own email server and your web server and da-da-da-da in your own facilities. But now with cloud, you just buy into a cloud, and then you scale on demand. So use, for example, Amazon web servers or whatever they use. Same thing for email, same thing for file sharing, communication, Slack, all this stuff, Trello, all of this stuff. It's on the cloud, right? There's no point in having that physical hardware at your locations. And maybe it's kind of a salty analogy, but I'm just thinking maybe we sort of the same thing with keyboards and monitors and things like this. They just turn into part of the IDE, and IDE turns into that. So you interact with your source code, and your source code has a representation. And currently, this representation is all text. It doesn't matter if you use Sublime or Vim or Emacs or Atom or Visual Studio or WebStorm or Eclipse or whatever, all of these things. Right? It doesn't matter. It's still just text. So the representation is essentially the same in all of these IDEs or these text editors because it's text. We edit text. So what I'm saying is that when we push this further, you'll have apps that have completely different representations of the program. So on a basic level, you have visual representations and sound representations and tactile representations. But even beyond that, you now like 3D print your program. You may have like a feasible button, right? But that's on the first level. But on the second level, even within the context of visual representations, you have different vendors doing different visual representations, right? Because one size doesn't fit all, you all have to think differently. So instead of trying to use the same visual representation for all people, there are different visual representations, and you can choose whichever visual representation suits your own. So if I try to sum up that, those are multiple points, right? We're talking about portability, but we're also talking about customizability at very low cost. And if you start to push that further, I think this is where it becomes really kind of interesting. Because programming today is textual, experience of programming. Maybe you don't even need to know language when you start to write your first program. You're writing your first program, right? I'm talking about like education, where maybe you can push programming from very early age. Age when you don't even know how to write sentences yet. Think about that in kids where you have triangles and balls and squares and you push them through different holes. You kind of become that pattern matching exercise where you just pull things back and forth and put them here and there, and with these Lego blocks build the program. It's kind of like that Scratch thing. There's this program called Scratch that teaches kids to program. I haven't looked extensively at this, but it seems to me that they're very much using that type of thing where they're trying to think in terms of tokens rather than in terms of language. And I think that's really solid. That's really the direction we want to move in. Because I really believe that you could probably make programming a very part of education, right? It could become like when you start to learn about language and math, right? Like very small kids. Even maybe before that, maybe you could end in a game, right? With small kids. Yeah, but now I'm going off topic. So let me wrap this up here. I hope it was okay to follow along with that brand. If this freaks you out and you really want me to stay away from this kind of video, you let me know and I will try to not do it again. But beyond that, we are the keyboard generation, or the desk generation, the workstation generation. And it's really time that we seriously start to think about how to move away from this, I would venture to say, physically straining type of activity. It's kind of absurd. It's like people will look back at our generations and will say, wow, that was kind of evil the way they were working. You can feel it now that it's primitive. It's very primitive compared to how you imagine that we should be writing programs. So that's it. Thanks for watching. Remember to subscribe if you want more rounds like this, but also, more importantly, a lot more concrete talks about code, about